Most people at UBC don't know where the electricity supply comes from or how it gets to this point. They just expect it to be there when they need it. To better understand how the UBC electrical system works to allow power to get here, let's take a step back. UBC Energy and Water Services provides approximately 50 megawatts of electrical power to the entire academic campus. And the main campus distribution hub is located here, at UBC's main campus substation, formerly known as UNY Substation, right beside our Campus Energy Center. But where does UBC get its power from, you ask? BC Hydro's Camosun Substation, approximately 5 kilometers away, nestled in a quiet residential area of Vancouver's west side. UBC is the sole customer supplied from a newly built $26 million facility that took 2 years to complete. UBC is supplied from Camosun Substation via two 69,000 volt transmission lines. Circuit 60L56 travels primarily along 16th Avenue, while Circuit 60L57 travels primarily through Pacific Spirit Park. Both lines dip below ground from UBC property line to the UNY substation. The two transmission circuits supplying UBC are strictly for redundancy. Each transmission cable terminates within the UNY yard. Power then travels through a myriad of equipment, eventually to two main power transformers. These beasts, each rated at 47 megawatts, transform the high transmission voltage down to 12,000 volts for easier distribution across campus. The two power transformers connect directly to the main distribution center within UNY that houses the feeder breakers for the entire campus, similar to a breaker panel within your own home, but much bigger. Each breaker connects to large feeder cables that run from UNY throughout the campus via underground banks of conduits called duct banks. There are 14 main feeders and 3 standby or backup feeders distributed across campus. The duct banks connect to a network of 300 manholes across campus, the largest of which is right out front of UNY. This manhole hosts every feeder circuit before they dispatch to different areas of the campus. UBC uses plug-and-play cable connections. The cables are bolted together and can easily be disconnected and moved to another connection point or feeder within any manhole to permit more even distribution to accommodate new building load growth. Eventually, with campus load growth, when all the available feeders are fully loaded, new feeder cables will need to be installed. UBC currently has approximately 30 kilometers of feeder cables distributed across campus. Of course, these cables don't install themselves. Energy and Water Services relies on our highly skilled utility electricians to install cables to service new buildings and replace old infrastructure. These cables are very large and weigh up to 10 kilograms per linear meter. 2 feeder cables are installed to each building, one main feeder and a redundant standby feeder to allow our electricians to work on any cable without affecting the power supply to our critical customers.
Well, here we are in a typical building main electrical room. Power comes into these rooms via underground conduits, concrete encased, at 12,500 volts, underground up into the equipment that you see here. We have 2 feeders, typically in a building, a main feeder and a standby feeder, both at 12,500 volts. These isolation switches and equipment will then redistribute the power to the unit substations, transformers in the adjacent room. So a substation is a piece of equipment comprised of transformers, isolation switches, circuit breakers, and distribution equipment for the purpose of transforming the voltage from 12,500 volts down to a voltage which is suitable for the end user of the building. The power gets distributed via circuit breakers and distribution equipment throughout the building, all wrapped up in a neat and tidy enclosure to prevent access to live parts.